Hi, my name is Price, and I'm a postbaccalaureate research fellow at the National Institutes of Health. Patients with a condition called epilepsy have sudden, uncontrolled electrical firing in their brains, known as seizures. Around half of people with epilepsy have focal seizures, which start in a specific part of the brain and spread outward. If medications don't help these patients, surgeons may try to eliminate their seizures by removing the portion of the brain where the seizures begin. However, these surgeries are not always a permanent cure because it's very difficult to precisely identify the entire part of the brain responsible for seizures. The goal of my research here at the NIH is to develop a new method to locate the region where seizures start. To find the source of seizures, surgeons implant tiny devices called electrodes in different parts of the brain to record the electrical firing. These recordings are useful when electrodes are close to the source of seizures, but they are not as helpful when electrodes are far away. To solve this problem, I used a technique called time difference of arrival multilateration. This method, which is used in radar and earthquake detection, compares the times when a signal arrives at detectors set up in different places to determine the location of the signal's source. My research uses the same principle, with the electrodes as the detectors and the abnormal electrical activity as the signal. When I tested out this new method, I found that in 3/4 of epilepsy patients who were not cured by their surgeries, this technique identified a potential seizure source that the surgeons had not removed. I hope that my research will help doctors track down seizures in the brain so that they can permanently relieve their patients' seizures.